first of all, welcome everyone. Good morning or good afternoon. Okay, so this is what I think. First, we have to thanks to Varun and Kalyan, who set the bench for us, and they made our job easier, much easier. So I think we all are talking in observability space, right? So yeah, what we see is from LLM to cluster. So we'll see the more like how we do RCA using GenAI stack. Okay, so yeah, myself Srinivas Venkata Bevara, and I'm working in Broadcom. And again, as Atul mentioned previously, this is our second session here. Indeed, it is a third session, but with CNCF Hyderabad second session. And again, we would like to collaborate more with CNCF Hyderabad even in future too. Okay, so I mainly work with observability product, and we use OpenTelemetry and OpenLit. And again, nowadays we are working more heavily in GenAI space. Again, you can see me wherever the CNCF or KCD or KubeCon anywhere happens. I think most likely you can see. If you are new, then just hi here, then we'll see in next future events. Shiv, just introduction.
Shiv Raj here. So I've been working with observability for last 8 years now, and so I have attended a few meetings. So maybe I'll continue attending them further.
Thank you. Okay, so this is the demo system which we'll see today, and next few minutes I'm going to show you how a real trace level visibility in autonomous agentic AI systems which you run in production. All these components runs live in the Kubernetes cluster, and let's see what is there on the screen. The flow starts from enterprise user. See, I'll try to keep it in a different direction because, as I said, Varun and Kalyan did the good job there already. Okay, so the flow wise, if you see, the enterprise user starts giving the prompt to the chart UI component, and then which sends to the SRE investigator. SRE investigator is our AI agent. Then it calls to the ChromaDB, serving as a RAG, which is our runbook knowledge base. And agent pulls the remediation steps and then enriches its output. Then agent also calls LLM MCP, goes via AI agent gateway. So AI agent gateway, again, open source initiative, which we used here, not just routing purpose, but we'll see here, whatever the agent gateway you see, it sits between the agent and LLM, and it sits between the agent and MCP server. It enforces the security and guardrails. So that is JWT, RBAC, tool filtering, anything reaches before to LLM and MCP server. LLM is, as you saw already, just for reasoning, and MCP is an agent hand to go into the K8s cluster. We have a K8s cluster where we are going to do the triaging case. Okay, so whatever you see, this particular stack is completely customer stack, which we are going to monitor it today. And let's see what is going to happen in next few minutes. Okay, so I think, as again I mentioned, these guys gave very good overview. Let me start with an incident, okay, rather than again going into the details of the agent and what is LLM, all these things. Let me start with an incident. But we'll take an example from OpenTelemetry demo application. It is maintained by CNCF OpenTelemetry community. I think it is a very famous application. You might have seen all these things. We are going to use agentic AI capabilities to triage the demo application. Okay, so let me make this concrete, right? So how many of you know OpenTelemetry or OpenLit here? Okay, how many of you are running GenAI in the production? Good number, I think that's great. Okay, so now let's make some incident from my experience. Okay, at 2:17 a.m. in the morning on Friday, checkout service started restarting. That is the one of the application which I said from the OpenTelemetry demo application. Okay, our SRE investigator, which you saw, that is the agent, our autonomous agent, picked up an alert. Okay, so then there is no human paging here. Okay, no one watching. So just picked up an alert. It called 4 tools out of the 8 Kubernetes tools, which you know all these pod names, pod logs, whatever it is the tools, right? So it called 4 and then it queried the RAG database and it did some investigation, came up with some recommendation step. You know what? After that, tier 1 operator came an hour later. Okay, he saw that still alarm is getting repeatedly coming. The same thing is coming up. The first agent, what it did, it simply gave the recommendation. That's it. It didn't do anything. The next one, what it did, so this guy came and saw, okay, let me try to force the issue. He saw this alarm is coming repeatedly. He tried to force the issue. What he asked the same agent to delete the hotel demo namespace and deploy it cleanly. Right? It's kind of a fast destructive action, but it works, right? So that's what he did. And this tier 1 operator not supposed to do that because you don't have a permission to delete. But here if you see, he asked an agent started to comply. It tries to delete. So then morning 9 o'clock, like as everyone comes to office, everyone came and saw that something happened. What are the 2 things? They came to know 2 things happened. One, agent did an investigation, gave the recommendation. Second, something deleted. But what they don't know, but they saw the logs. They know what exactly happened. They saw the dashboard. They understood the issue. But what they don't know is team didn't have answer to 4 questions. What are those 4 questions? We'll just see in a moment. Okay. So the rest of the time we'll spend here that incident which I just described, and what about the 4 questions? We'll try to answer. That is Shiv's job to show it in his demo. Okay, then we'll see agentic observability, how fundamentally different than a simple normal, any application monitoring or simple as standard LLM observability. Okay, that is what our goal for today's demo, and then we'll see a live scenario. We have constructed 4 preformed scenarios. We'll try to see and compare with our use case which we are talking about. And also we'll see deep end-to-end trace and then one investigation each and every span by span. Also we'll see the cost and everything. Again, back to the 217 issue, right, which I explained. What are the 4 questions? These are the 4 questions. First thing, which model made the call? You might have using 100 models, right? What is the model it tries to call? Was this actually authorized or not? This is very important point. Is the right person is trying to delete? Maybe it is a possible something real DevOps admin user wants to delete. That is a valid thing. But whatever the tier 1 operator did, that may not be valid thing, right? So was this fix grounded on the real data? Is it really your runbook is suggesting for delete and redeploy it namespace, or is it asking you to do it in a different way? What did it cost? Because whatever the decision comes, as these guys already explained to you, it don't come in a single go. It has to do in a loop, right? So it incurs a lot of cost. So again, back to traditional logging system, as I mentioned, it just tells you what it did. But how we find out with a real distributed transaction traces answers this question. Again, that is, as I mentioned, Shiv's job to explain this. Okay, so just to what you see in the first screen, I tried to little bit zoomed in this particular thing. Okay, before going into this diagram, let me share one industry thesis, shared one. It is mainly in agentic AI space. Okay, so what they say is traces are the new source of truth. If you don't have a traces, that we'll see in agentic AI observability main thing, you can't, is impossible to come to know the questions which I mentioned. You may get some other way, but here each layer in this particular stack requires different kind of evidence, right? So why I'm saying that, if you take an application monitoring, if something code fails, stack trace, which exact line got failed, because software is deterministic. That is what these guys said, right? Agentic observability is non-deterministic. Okay, so when it comes to the standard LLM call, if something goes wrong, it's a one prompt, one response. If you see the prompt and response, at least you know what, because it is constrained to, as I mentioned, one input and one input. But agent doesn't answer, it decides. That is what Kalyan and Varun already explained that, right? Which tool call it executed, which document to trust, what to do next. If you see, the completely driven by react, reasoning and acting and in loop. The same thing, do it again and again. That is where the cost is very much important thing, right? So the main problem is that I'm going to repeat what these guys said in a just little different way. Agent can fail badly. It looks like completely success. You will not come to know anything, whether it is an error or issue or whatever it is in the behind the scenes. That is what Shiv is going to show you. Agent wise, you would see completely positive output, but behind the scene, what is going is wrong, right? So this is where, traditional logs or dashboard can't catch the issue. It wraps up a wrong tool call in confidently, perfectly well-formed answer. It's a confident liar, right? So all the agents are like this, very confident. If sometimes, I think in KubeCon when I win something, they asked for some kind of how to sticky this one, they said use Fevicol or something. It very confidently says that. So that is where important thing, how you came to that conclusion. That is where we need to see each and everything. So hence, simple logs are not enough. You require a distributed transaction trace, a full end-to-end trace, where the complete, reasoning, context, and then tool calls, everything captured at each and every layer. Okay, let's come into the little bit technical to it, how we collect the data from this. If you see chart UA, which we have deployed it in Python, hence we are using OpenTelemetry Python agent. You can see the icons there. So when it comes to the SRE investigator, as I mentioned, it is a agent. Still, we used it in a Python. We used the Python OpenTelemetry agent. Plus, you can see one more icon that is called OpenLit. Why I used OpenLit only here, not at the top? Because this is the guy who is giving a client calls to LLM, who is giving a client call to MCP. I want to track them in a different manner. Hence, I used a OpenLit. OpenLit is a sub-community of OpenTelemetry. I think, hope you everyone aware of it. It is specialized for GenAI space. Not just OpenLit, here we used OpenLit, you can use OpenLLMetry, OpenInference, these are all open source. You can use anyone, we all support this. So here for an example, we used OpenLit, then the call goes to the ChromaDB and agent gateway. As I mentioned, agent gateway comes up with inbuilt observability. This is the observability 2.0. Most of the application, if you name it, you don't need to even instrument with the agent, out of the box, not required. By default, they are coming with the observability. That is the power of OpenTelemetry now. Okay, so you get the all traces, that is more real time. You can simply give, they push the traces to the direct collector, but agent gateway gives the scrapping endpoint where OpenTelemetry collector can scrap that data. Okay, so then what we do here, traces will be coming directly, but whereas OpenTelemetry collector go and pull the metrics. The same way ChromaDB and MCP server, we have, again, it provides the OTel native data. We have not done any instrumentation there, but we are using the inbuilt capabilities of what they provided. Okay, so if you see here, MCP, let's take an example. MCP here 4.1, we did a native observability. Then agent gateway, again it is providing the native observability. Then SRE investigator, we made instrumented using OpenLit. It provides the client call. That means 1, 2, 3, and then final call to the cluster. 4 spans when Shiv sees, shows the transaction trace you are going to observe there. The same way, the gateway calls. Okay, let me not spend too much time here, but for LLM Gemini we are using in the example as an MCP, we are using a K8s MCP server, which is in containerd/ open source one. Again, we are using as is, so which will interact with our cluster. Then OTel collector, I think everyone is aware of this hotel collector. It is the most important crucial component of the OpenTelemetry ecosystem, right? This is their flagship component if you see. So it contains internally three things: receiver, processor and exporter, right? Whatever you see in the 1, 2, 3, 4, 5, everything data emits in the format of OTLP, that is OpenTelemetry protocol, and data comes to the OTLP receiver. Then OTLP receiver sends data to the, it fans out basically to the processor, where the processor does batching, filtering, enrichment, transformation. There are many much more wide varieties of, if you see the OpenTelemetry contrib, and you are going to do. And I contribute there, OpenTelemetry collector. Okay, and coming to the next one, if you see the from collector to it fans out to again exporter where you can use any observability backend. Here we are going to use the Broadcom DX02. It's our inbuilt observability tool. So we are going to make use of this from hotel collector to Broadcom DX02. Again, this DX02, just would like to mention one particular point. I think if you heard about last year KCD, we gave one talk where it delivers 4 million PPS per second, metric points per second. But I can tell this year for one of our customer, we certified with a 7 million metric points per second. So why I am trying to mention is that, so not just collecting the data in agentic AI, as it sends a huge amount of data. So you need to have some kind of observability backend where it can take that data. Okay? Yeah. So just to wrap it up, you can easily configure this. All we follow the OpenTelemetry standards, OpenLit standards. It's just matter of a one line where you can add this particular thing. Again, it is evolving. Easily you can add, this particular things. I will not go through that. Shiv is getting timed out otherwise. Yeah. Again, we are vendor neutral completely. You can do all the orchestrations, agents, and Olama, and all 50 plus LLM providers, including the LangChain, ChromaDB, all these guys we support. Okay, so without much wait, I'll hand over to Shiv.
Yeah. So as part of demo, these are the 4 scenarios we are going to cover. One being regular scenario which Srini mentioned, right? There is a problem in the Kubernetes deployment, and user wanted to know why exactly a particular issue is appearing. And there are a couple of unauthorized activities users wanted to do, and we will be showing how those are get flagged in the trace monitoring. And last one is the prompt injection attack, which I'll be demonstrating.
Oh, should we use this? Okay. Yeah. Okay. But you have 7 minutes and just. Two speaker issues.
App looks like we have a SRE investigator agent which uses RAG, MCP, and the LLM models to triage the issues which customer might come up with. So the first scenario we have is a regular scenario where an issue is appearing and user wanted to know what exactly is causing this. So this is how you would run it here. As of now, it is like one particular query is baked in here, and it would take a bit of time. So let me show you how it would appear here.
You want to maximize?
Why is it not going back? Right. So yeah. So basically. Right. So basically, there are pod restarts which are happening, and the user has queried about it, and this is what the recommendation. So the green portion you see here is the recommendation, and the last ones are the tool calls which were made to identify what could be the issue behind it. So so this is how it is appearing, and these are the tool calls which will be seeing how it comes on the trace view. So coming to the trace view here, right? So as you can see, the first one, the duration is for the entire okay, yeah. So the first two are the ones which represent the call to the application. The first one is the UI, and the second one is the agent here. And as you can see, this first makes a call to the SRE runbook. Here the call to ChromaDB is made. Right. So right. So here, as you can see, let us. Right, so the DB system is coming as ChromaDB, and there are some metrics related to GenAI semantics. We have the documents which got returned. So whatever was the query, it got embedded and was the request was sent to ChromaDB, and we got 3 documents. Next, what the agent being the orchestrator. So what agent is trying to do here is that a query has come. It has queried with the React database to identify the relevant documents. So the React database you can think of as a instruction manual. So if you have encountered an issue, what all portions of those manual can be used. So those all documents are refreshed. And next, we also try to get what all tools are available to our GenAI model. So next we make MCP calls, we initialize it, and then we get the tool list, which we can see here. So these are the ingredients of the data we push to LLM model. So LLM model now has what all are the capabilities the MCP server has, and what all are the documents, instructions which it is recommended to do. So it is automated system. There is no manual person required to go through all those documents and make the required calls. So what happens next? We have this Gemini. So the call, the Gemini is taking some 4 seconds. It has got all those data, and it does some processing, and we can get all the relevant information here, in the sense that okay, it decided there is a finish reason here, that there are more tool calls required, and what is the response model used, what is the usage, tokens used, output token, and all such things. So as we saw that the finish reason is tool call. So what GenAI has decided here is that there is more tool call required, and we will be seeing, as we saw before, we had two tool calls, right? So first tool call is here, right? So it made a tool call, the pods list in namespace, and then all that data goes back again to the GenAI. So now that data has been fetched from the tool call. Now GenAI again does processing. Again similar set of data, and so what we are seeing here is that with this monitoring for the trace, we are getting what all are the tokens used, what is the finish reason, and what activity exactly is happening here. And again after this, if we see, there would be again a tool call required, and then eventually we will have a response being generated. So if you see here, there is a endpoint here is
and that's it. Yeah.
Right. So the endpoint here is generative language thing, and if you see, go to the parent of this, you can see that this one, right? So here, if you see this chat Gemini call, here the finish reason would be stop, and when it says stop, it means it has arrived at whatever is the conclusion for this, and it returns the response which we saw in the green section in the app.
Yeah, just to add one more point here. So as I mentioned, who did a call and all these things, user identity, you can see here end user ID, which is the the user name, and then is scope, what he is supposed to execute. I think, yeah. So you can see the admin metrics. He has admin permission and all these things. So again, these are all things based on the OpenTelemetry resource semantics. We simply follow that, and agent name, conversation ID. This is where the call started. As Shiv explained, MCP when it initiated, he showed initialize and that. That is the life cycle of when agent tries to establish a connection. Initially does the initialization, then it tries to discovery, then it did a real tool call. That is what he explained, two tool calls. Finally, you might have seen something called delete. So that is where it tries to delete, terminate the connection. So you can see the complete activity, but each LLM call before that there is a Gemini chat particular trace he showed it. So that means this is the LLM took the decision to do this particular call, and that's why the tool call happened. So that way you can see the completely. You continue.
Yeah. So basically the next scenario. Yeah, so the next scenario here is that there is a, as Srini mentioned, person came and he tried to, in order to resolve the issue, he instructed model to this agentic AI to do some activity, and it asks it to perform a delete action. So as we can see, this person is not authorized, and we see here that what is the error response here, and the gateway request denied. So what happened, this agent, we have an agent, it has got a set of tools which it can execute, but at the same time we have agentic gateway which limits the activities a particular user is allowed to do. So those that particular trace. Yeah, so this is what the trace would look like here. So here,
network issue taking time.
Yeah, so here you can see, right, same thing which we saw on the app layer. Person who is monitoring this particular app would see that gateway request denied, and as Srini mentioned before, right, so here the user, we know the user is
below. Come down and use.
Yeah, so end user ID here is Mark, and his scopes are to read metrics and logs. So he tried to perform activity which is beyond its authorized, beyond his authorization. So those all got rejected, and we see those as errors here. Similarly, there is one other activity where a person, he tries to read logs, but he doesn't have the permission to read the logs. Right, so
prompt injection.
Yeah, and the similarly we will see, like if there are other error scenarios, if we looked at it, covered the traces, we will see those all details as part of the traces here. And there is a scenario where we have a prompt injection. There is no error as such, but if we investigated the traces, we will find that so there is a prompt injection which is flagged here, and we see that guard score is 9. So what we are, what scenario we have here is that we are trying to get the pod name for test ng in the test namespace. So this is a particular thing which sounds fishy. It is like it is not something which a person is supposed to do, and the same when we see here on the trace view.
Just to add here, this is what Kalyan showed the score, right? So what he tried to do is called instruction override. This is a guardrail provided by OpenLit. So what he's trying to do is telling the system, you know what, you just simply listen to me, do whatever I want. This kind of instruction when you give, this particular guardrails will help you to identify the prompt. If you see, the trace is completely green, but behind the skin it is giving you score. And again, it can be done in two ways, OpenLit. One, you can use the OpenLit internal regex based pattern, or you can use another LLM as a jet and you can use that. facility. So any of these things you can use and make use of this prompt injection. This is a one type of a guardrail for an example, but you have much more, and you have evals as well. So these are all things provided by OpenLit. Feel free to do, and our trace can capture completely and provide the feedback to the user. Yeah, anything else?
Analysis.
Yeah. No, that's okay. You can continue. You cover it.
Yeah, so there is one analytic tool we have got to give analysis.
Dashboards and
Yeah, so in that so for those metrics we have got dashboards as well here. So whatever the request tokens, cost, all those things, right? Those all get covered as part of this dashboard. So total requests which was there, and total. So this is the agent gateway overview. So we get all these here.
yeah, one more triaging. Just one more minute, we are done. It's stopped. Yeah. Screenshot it. बहुत टाइम लगेगा.
नहीं, इसमें क्या कहाँ पे है बताया क्या?
चैट में दिया.
Meanwhile, if anyone have queries or questions,
You want to show here? Yeah, it's ready. डाल के दिखा.
Sorry again, change of screen. ये लगा दो. ये बता दो.
You can take questions meantime. Do triaging manually, trace by trace, span by span, everything. But you don't need to do no more anything. GenAI on GenAI. So if you come here and just click the button, you see it's a nice summary, provides everything. So what happened, what kind of authorization calls happened, there is a ChromaDB issue happened, everything comes together just on one click. So you just click on this, you get the complete summary, what are the things which you did manually, everything is going to tell you what user happened. Then also it brings all these signals together. It's not just showing you, and then go down and you can explain all these things like what kind of a matrices happened, alarms what it contributed, and events. Again, we don't have a time to go in depth, but it gives very good kind of a matrices and all these things with how suspects happened, all these things details. But I think we can cover in next session. That's okay. Again, thanks Shiv for covering all these details.